Here we have a SAT math question. Okay, let's go with the information. Dominic is allowed to play up to 8 hours of video games this week. He wants to play video games for at least 4 hours this weekend. Which of the following can be used to represent T, the number of hours he can play video games before the weekend? Okay, first let me write some stuff over here. I have written the stuff over here. According to the question, T represents the number of hours Dominic can play video games before weekend, and I assume W represents the number of hours Dominic can play video games during weekend. And there is an information over here. Dominic is allowed to play up to 8 hours of video games this week. So that is the total number of hours he can play video games this week can be up to 8 hours. That is, it can be equal to 8 or less than 8. So that to get the total number of hours, what we need to do is we have to add T and W. That is number of hours before weekend and number of hours during weekend. So this T positive W can be up to 8. That means it can be equal to 8 or it has to be less than 8. And also there is a restriction for the number of hours he can play video games during weekend. So here we have an information. He wants to play video games for at least 4 hours this weekend. So for weekend we have the variable W. Since it's at least 4 hours, then the W, that is the number of hours he can play this weekend, can be equal to 4 or it has to be greater than 4, because at least 4, the minimum value of W is 4. Okay, so if I consider the minimum value of W4, then what can be the value of T to satisfy this inequality? So the maximum value of T can be 4. So that when I take the minimum value of W4 and maximum value of T, 4 positive 4, 8, 8 is less than or equal to 8, it satisfies the inequality over here. Okay, here we have a question. So what if the W is greater than 4? That is, for example, if W equals to 5. So what is the possible value of T? So definitely T has to be less than 4, because if W equals to 5, if I take T equals to 4, there is the maximum value of T, what will happen? So when I add 5 positive 4, it's 9. 9 is less than or equal to 8. No, that's false. So when W equals to 5, T must be less than 4. T can be 3 or less than 3. It may be 2 or even it may be 1. So like for example, when I take W equals to 5 and T equals to 3, we get 5 positive 3, 8. 8 less than or equal to 8, it satisfies the inequality over here. Or if I take W equals to 5 and T equals to 2, 5 positive 2 is 7, 7 less than or equal to 8, again it is satisfied. Even if I take T is equal to 1, then W equals to 5, 5 positive, W is equal to 5, T is equal to 1, 5 positive 1, 6, 6 less than or equal to 8, that's also satisfied. So from the given condition, I get the number of hours he can play during weekend is greater than or equal to 4. That is, W is greater than or equal to 4. And the T, the number of hours he can play before the weekend, we have the inequality. So it has to be less than or equal to 4. Okay, now when I go over the options here, in each option, we have an inequality in terms of T. So solving which of these 4 inequalities will give this solution T less than or equal to 4. That's what we have to find. Okay, now let me verify the first option, that is A. I'm going to solve this inequality for T. So for that, let me take this over here, T negative 8 greater than or equal to 4. Let me add 8 to both sides. When I do so, this negative 8 positive 8 will cancel. I'm getting T greater than or equal to 12. But so when I solve the inequality in option A, I don't get this one as a solution. That is T less than or equal to 4. Okay, now let me check the inequality that we have in option B, that is T negative 8 less than or equal to 4. When I add 8 to both sides, so I'm getting T less than or equal to 12. Again, I don't get this one as a solution. So option B is also incorrect. So we can reject option A and option B as well. Okay, now let me verify option C, that is 8 negative T less than or equal to 4. Okay, now to solve for T, let me subtract 8 from both sides. This negative 8 positive 8 will cancel. I'm getting negative T less than or equal to when I combine this, I'm getting negative 4. So here we need positive T on the left side, but here we have negative T. So to make this negative T as positive, what I have to do is I have to multiply both sides of this inequality by negative 1. So whenever I multiply both sides of an inequality by same negative value, I have to flip the inequality sign. So that is, I multiply both left side and right side by negative 1. So when I do so, I have to flip this inequality sign, then it will become greater than or equal to. Negative 1 times negative 2 is positive T greater than or equal to negative 1 times negative 4 is positive 4. I am getting T greater than or equal to 4, but here I am getting T less than or equal to 4 using the information we have in the question. So in option C also, we don't get this solution. So we can reject option C also. I think option D must be correct. Anyways, we can verify. So let's reject option C. 8 negative T greater than or equal to 4. Okay, now let me subtract 8 from both sides. When I do so, this positive 8, negative 8 will cancel it. I'm getting negative t greater than or equal to, when I combine 4 and negative 8, I'm getting negative 4. Now I multiply both sides by negative 1. So when I do so, I have to flip the inequality sign. It will become less than or equal to negative 4 times negative 1. So negative 1 times negative t is positive t, less than or equal to negative 4 times negative 1 is positive 4. Okay, when I solve the inequality in answer choice D, so I'm getting exactly the one what I got it. So I mean I got the inequality which I get it from the given information. So the correct answer choice for this question is option D.